So boiling points, melting points, density, solubility, those kind of things, where we want to separate two different things. Whereas if I was to try and do the same in lead, so filtration is a common method for removing. So today's lesson will be separating mixtures and all of the various techniques that we use to actually separate mixtures in the physical world so that we can get chemicals that we desire. So the need for separation. Why do we actually need this process? Often substances that we want or need are bonded to other chemicals in the environment. So for instance, you rarely find any metals like iron or copper just lying around in a lump somewhere on the ground. They're usually bonded to other things, so we need to be able to separate these things so that we can get the iron or copper back. So in the previous lessons, we've talked about aluminium refinement, and that's an example of how a mixture needs to be separated before we can get a useful product. Often these natural substances need to be separated from impurities to get the substance that we desire. Now, in order to separate mixtures, we can use a number of different techniques. And these are based on the physical and sometimes, well, mostly the physical properties of the chemicals that you want to separate. So the techniques presented are based on physical properties and can't be used to separate compounds into elements. So I'm about to talk to you about different separation methods. They're all based on these physical properties. So boiling points, melting points, density, solubility, those kind of things. So we can't use these to actually separate these compounds like aluminium oxide into elements like aluminium. That's where we're going with this lesson today. We're going to talk about separation in terms of basically scenarios where we want to separate two different things. So the first scenario is separating solids of different size. In this case, we have two solids that are different size in terms of their grain size, and we want to separate them. So two common methods is to use sieving or centrifuging. For those who bake very regularly, you would use a sieve to separate the flour in order to get a very fine mixture of flour at the bottom. Sieving uses a fine mesh to allow particles smaller than the pore size, so the size between the metal mesh, to slip through while blocking the larger objects. So the larger parts are stuck by the very small holes, and the very fine particles get through because they're obviously smaller than those holes. This process is used to ensure a fine distribution of flour for baking. For baking purposes, you'd use this to get a very, very fine and even distribution of particles through your flour. So you wouldn't get any big clumps, essentially, is what we're saying here. That's sieving. And it's basically, the property that we're exploiting here is that, one particle is simply bigger than the other particle. And that's a physical property. It's size. So one particle is bigger than the other. It can't get through the hole. So that's the property we're exploiting. So as I go through this, try and think about what properties we're actually exploiting before I tell you, and then it'll help you clarify what these processes are actually doing. So we actually can use sieving in industry to separate valuable ores from waste rock. So we can actually sieve larger rocks that are useless from smaller, more valuable rocks. Now another way to do this is through centrifuging. So centrifuging is a common separation technique that exploits the density differences of different substances. So we're saying that some substances are more dense than other substances. And that's pretty obvious. For instance, air is not very dense. I can walk through it, I can run quite slowly through it. Whereas if I was to try and do the same in lead, that would be much, much more difficult. I wouldn't be able to run through lead, just run into lead. And it doesn't float, it's very heavy, so it's very dense. In centrifuging, what we're exploiting here is that some particles are naturally more dense than other particles. So when you have a solid suspended in a liquid, sort of like how blood cells are suspended in blood, gradually, the densest substance will settle on the bottom. If you've got a container, I'm sure you've seen this before. If you shake up a container and there's sand all through here, eventually, over time, all of the sand will drop to the bottom and it'll settle. I'm sure you've seen this. And what we call this is sedimentation. When things start falling to the bottom, we call it sedimentation. Now, centrifuging is simply an accelerated version of sedimenting. What it does is it spins the suspension, so it spins the liquid at very high speed. I'm sure you've seen this in sci-fi movies and things like that. You put it in this little container and it spins, and at very high speed spinning. What happens is when you spin it, it essentially imparts a force on each of these particles. And because some are more dense, they'll fall to the end of the tube faster than the less dense particle. So centrifuging is used to separate solids in a suspension. And what we do is we use it in the separation of blood. So when you go and donate blood, they take out the blood and sometimes they'll separate it into parts. So they'll separate it into blood cells and different proteins and things. You can use each of those parts instead of having to use whole blood. It's also used to remove fine particles from gas streams. A similar method is sort of like if you have a Dyson vacuum cleaner, the cyclonic action sort of operates the same way as this. So for those who use Dyson vacuum cleaners or clean your house regularly, this is sort of the process that's used to extract dust. This is a more common one. We rarely see many examples of separating solids from solids, but now we have separating solid from liquid. This is quite easy. So filtration is a common method for removing solids from fluid streams. Filtration is very easy. You're relying on the particle being not soluble in the liquid and then letting the liquid pass through the filter, whereas the solid gets stuck. Similar to filtration similar to sieving, except one of the substances is now a liquid. That's the only difference. The property here is that it's insoluble. The solid is insoluble in the liquid. That's our property that we're exploiting here. Now, filtration uses a fine mesh to allow fluid particles to slip through while blocking the large solid particles. So that's what we're doing in filtration. I'm sure you've got water filters and things you've seen, pool filters, and that basically is how they work. So we commonly see this process being used in water purification to remove large particles from the water stream. Often it's done with sand or carbon as a filter. So these are very nice filters. They work very well, and they actually remove some bacteria and things as well. So they're very, very good for filtration purposes. Now, another way to do this is through froth flotation. Froth flotation can be used to remove solids from liquids as well. And we use it in mining to remove minerals from waste rock. So often what happens in mineral refining is we dissolve the rock in some kind of chemical, and then we actually try to remove the waste, or we try to remove impurities, because the impurities dissolve whereas the metal stays as a solid. So the metal will be the solid in the liquid, and all we have to do is get that out because we want that. Crushed rock mixture is placed in a tank of water, detergent, and some oily chemicals. Air is pumped through this liquid, forming a froth. Minerals adhere to the froth while waste rock does not, so the waste rock kind of just falls away to the bottom, and so the minerals actually accumulate at the top. Then the froth is scraped off the top and the minerals are extracted. Basically what happens is we crush the rock up, the impurities, the rock are all thrown into water, you bubble air through the water, that forms bubbles. The minerals actually adhere to the bubbles and come to the top, as you can see in this picture, and then you just scrape the top off to remove the actual minerals, and then the waste just goes away. Now, what about if we now have a dissolved solid? Salt, say, will dissolve in water. So how do we separate those two? Well, evaporation is the most common. All we do is just evaporate the liquid from the solid, and then you're left with the solid. And that's how we get salt, like table salt from the sea. We just take seawater, evaporate all water, and you're left with salt. So energy is used to heat the water and evaporate it. So heat, light, those kind of things used to evaporate the water. So the dissolved solid crystallizes when there is no more water. And that's the property that we want. It crystallizes when there's no water. That's essentially the property we're looking for here. So the process is contingent on the solid having a much higher boiling point than water. The property we're exploiting here is that the solid that's dissolved has a really high boiling point compared to the liquid that it's dissolved in. So for instance, salt may have a boiling point of 1000 degrees Celsius, whereas water is 100 degrees Celsius. So you can see there's a big difference, and that's what we're using to our advantage here. We're saying that, well, because we can't boil this solid, we can boil this water and it will go away. What will be left over is just solid salt. Okay, so that's what we're trying to do here. And it's used, as I mentioned, in the production of table salt. So seawater is evaporated, leaving the salt behind. So here's a typical salt factory. You just leave out seawater in some open tanks and let the water evaporate. What if we have two liquids that are mixed together? Then we have another issue. We've got, say, ethanol and water are always together. So they mix together, and how do we separate them? Well, we can use a thing called distillation, and this works if the two liquids are soluble in one another. For instance, ethanol and water are actually soluble in one another, so they'll dissolve in one another. So we can use distillation to separate them. This won't work very well if they don't dissolve in water, like oil and water. That won't work so well. Similar to the evaporation concept, it relies on the two liquids having different boiling points. So one boils faster than the other, essentially. So we heat the mixture to the boiling point of one of the liquids, and that's the liquid with the lowest boiling point. So we heat the mixture to the temperature in which chemical that boils at the lowest boiling point will start to boil. So for instance, the boiling point of ethanol is about 78-ish degrees Celsius. This one's 100 degrees. So we heat the liquid up to this temperature, and what happens? The ethanol starts to boil, and then the ethanol leaves as a gas, but the water remains liquid because it hasn't reached its boiling point yet. So you can see how that helps to separate it, because this one leaves as a gas, whereas this one is still liquid because it hasn't reached boiling point yet. The lower of the two boiling points, that liquid evaporates, leaving the other liquid in the flask. You can then condense the vapors and then form two separate liquids. So if you trap the gases and condense them, you will get two liquids that are almost pure. This process is used in the refinement of petroleum, like petrol, and also the refinement of ethanol. When you get ethanol for your car from fermentation, you can use this process to get very pure ethanol. That was for two liquids that could dissolve in one another. But what about two liquids that can't dissolve in one another? like this one. This is oil and water. The top is oil because you know that oil sits on the top of water, and the bottom is water. So we can use what's called a separating funnel. This separating funnel actually relies on the two liquids being insoluble and one being less dense than the other. So water is more dense than oil, so it sits on the bottom, and oil is less dense than water, so it sits on the top. So oil is the less dense one, water is the more dense one. So one liquid will sit on top of the other due to the difference in density. Because it's less dense, it will sit on top, right? That's why hot air rises. So what happens is, see this valve at the bottom here? We just open it essentially. So we open it and the liquid at the bottom leaves. So we're draining out this liquid, and then we close the valve when we see that it's about to hit the oil, okay? Okay, so lastly, there's also mixtures of gases. We've talked about separating solids, separating different types of liquids. Now we're going to talk about what about gases. Similar methods to separate liquids that are soluble in one another. We use a similar method to separating liquids that are soluble in one another, because gases are essentially soluble in one another. It's called distillation. And again, it relies on boiling point differences, whereas it's slightly different from chemistry point of view simply because instead of heating it, we actually cool the gases. So basically what happens is gases are cooled until they condense. Gases with the highest boiling point are removed first. They become liquids because they have the highest boiling point. So you cool them, they become liquid, and then you can sort of siphon them off. Then you continue to cool them, and then another gas will condense. Then you can siphon that one off and keep going until you've reached the last gas. So it's essentially the reverse of liquid distillation. Instead of heating it, we cool it and turn it into a liquid. So we turn a gas into a liquid, whereas in liquid distillation, we heat it and turn a liquid into a gas. So there's a slight difference there. This process is used to separate the components of air. So for instance, if you've ever wondered how they actually get liquid nitrogen, just to be liquid nitrogen, they use this process. They condense the nitrogen into liquid, take it away, and that leaves over some oxygen and whatever else is in the air at the time. Additionally, we can use gas centrifuges to separate mixtures. When the gaseous mixture is spun at high speeds in the centrifuge, the heavier molecules collect at the side. So bigger gas molecules will stick to the side, whereas the lighter ones will be in the middle. This leaves a mixture near the center with a higher proportion of the light molecules. So you'll have light molecules in the middle, heavy molecules on the outside. This process relies on the gases having different molecular weights. So the molecular mass of each molecule is the property that we're exploiting. So each gas has a different molecular weight, which is a property. And so that's what we're exploiting in this case. And we use this in the production of some radioactive materials. So this covers all of the separation techniques that we use to separate different mixtures. So we talked about separating solids from solids, solids from liquids, liquids from liquids, and gases from gases. So we've looked at all sorts of different separation techniques. And so hopefully you've learned something about the different separation techniques that you've seen, and hopefully you've understood what each one does. So we'll move on to the question segment now and see if you can answer some questions.